The Air Force's Sustainment Center's mission is to sustain weapon system readiness to generate air power for America. The center provides winning expeditionary capabilities to the warfighter through world-class depot maintenance, supply chain management, and installation support. They are responsible for $26 billion in assets, generating $16 billion in annual revenue. The AFSC provides critical sustainment for the Air Force's most sophisticated weapon systems and software. We are proud to have AFMC senior leadership here with us today to hear more about the Digital Depot.
Good afternoon. My name is John Graves, and I am a principal management consultant at TACG LLC. Some of you may recognize me, but I certainly see some familiar faces out there from my current position as a maintenance, repair, and overhaul initiative team member, and earlier as an AFMC A4N, working in logistics and during ECSS, Escape, DEAMS. TACG LLC was founded in 2006 and is a federally recognized Alaskan Tribal 8A. We focus primarily in the public sector and aerospace industries. We are currently engaged in numerous areas such as logistics and operations, information technology, healthcare management, financial management, and workforce development. Today I am here and have the distinct pleasure to introduce our next keynote speaker, Mr. Jeffrey Sick. Mr. Sick is a member of the Department of Defense Senior Executive Service and is the Director of Logistics for the Air Force Sustainment Center at Tinker Air Force Base, Oklahoma. Mr. Sick coordinates logistics capabilities for a workforce of 43,000 personnel across the 3 air logistic complexes, 2 supply chain wings, and 3 air base wings. Mr. Sick has over 31 years of experience and has served in a variety of positions to include program management, squadron command, deputy material ground command, maintenance group command, and culminating as the logistic director vice commander. Please join me in welcoming Mr. Jeffrey Sick.
All right, thanks, John. All right, well, thank you. It's great to be here. I know this is about Wright Pat in Ohio. I sat through the previous panel. That was really fascinating. And I was just joking with Dr. Meister and some of the crew, some of the Accenture guys, that I'm just glad to be here at an IT conference and not talk ECSS or RICE objects or business systems and all that. I'm just glad we're here talking different stuff and looking in different directions. We still got to do it. I spent all day yesterday talking all that stuff. We still have to walk and chew gum, as I was saying. But it's refreshing to be able to come and talk to you about the other stuff that we are doing besides modernizing our business systems and the information technology to support some of that. So I really appreciate that. So thanks to AFCEA, great job doing this. Thanks to Yvonne, thanks to Tim Meister, thanks to the whole crew that are working this. Really appreciate this. It's a great effort here. So I'm from the Sustainment Center, so we've obviously got the big footprint at the big depots, but a lot of people don't realize the Sustainment Center is spread across not just the United States, but we've got a footprint in Kadena, Japan. We've got a footprint in Europe. As we say, the sun never sets on the Sustainment Center. And so even though I'm going to talk mainly about the big depots and modernizing them and digitizing the depots, I have to come here. It's kind of a paid political announcement by the Sustainment Center leadership that we've got to remind everybody that we also do the supply chains for the Air Force, both our 448 supply chain wing as well as our 635th operational wing. They all have multiple geographic separated units, so you'll notice that we're not just at Utah or Georgia or Oklahoma, that we've got footprints in Langley. We've got teams out at Scott and with Air Mobility Command. We've also do software. So part of the complexes, they used to be the software maintenance groups. We called it maintenance. We're realizing that we don't just do maintenance to software, so now there's software engineering groups. And we're looking at a federated approach and perhaps even more of a connected approach to align all of the software effort that the Air Force is doing. And so we've got geographic presence, with Lockheed down at Fort Worth. We've got teams down in Florida working the B-21. We've got teams up all over the place and all over the world. So the sun never sets on Air Force Sustainment Center. We've got a footprint here. So I'm in the logistics directorate. We've got 7 divisions, little known fact, but 5 of my 7 divisions are up here at Wright-Patt. So we've got bits of what used to be the Air Force Material Command's depot directorate in A4. It kind of merged into us. We've got bits of the supply directorate that used to be up at the MAGCOM level, and it merged down into us. We've got the supply chain, wholesale policies, processes, functional systems. We've got the IT office, so Dr. Meiksner, who works for me, and we're kind of running the digital piece and the Air Force Control System networks. And what I'm going to talk about today is a huge effort that we're working. We do ops research for the Air Force and coordinating a lot of the strategic analysis along with the 9 shop. And one thing I say is we're kind of the A3 through 10 for the Sustainment Center. We run the operations, we run a little bit in the middle of planning, we do even the comm, we do infrastructure and our MilCon, and then we do the 9 shop, and then we even do some nuclear stuff, managing those systems. But today I want to focus a bit more on what are we doing in our depots, where we're going to go, and how's it tied to you. So we've got a lot of folks, when you think about the Sustainment Center, I think you do probably think the depots, but you might think of just 1 or 2, but we're now all together, all 3. I love the fact we mentioned Gemba walks in the previous panel and lean. That's kind of at our basis, right? So Deming and lean and those fundamental foundational pieces we pound into the heads of every single one of our troops, from a young airman that just comes in to join us, or a young civilian federal worker, all the way up to the most senior that has had to go through all these different programs and a curriculum. So that's at the basis and across our 32,000 personnel. We've got, again, 24/7 ops. We live in a very old and work in very old architecture and infrastructure. And so I'll go into that, a bit of a history buff, and we'll talk through some of that, of some of our facilities, even are up here, right, tied back to the Wright brothers. A lot of it even predates the Air Force and its existence is, of course, Army Air Corps, even before a lot of that, and when we get into the Signal Corps and how the pieces are. But so the infrastructure and putting that in place to support all the digitization efforts we want to do is also a big effort we're trying to work, and we'll talk through that today. We'll talk about the path of Industry 4.0 and how it's working and how we're trying to push, even at the DoD level, kind of leading the way as to where the department is going for the future. And then also, it's not just about the technology itself. It's not about piloting in some effort in a silo. It's not just about doing one demonstration or even having a single innovation cell, but it's connecting it all and working it across the multiple different domains. And how do we tie that together? How do we support our customers? And it's not easy, right? It's not easy. So this picture here. So on the far left, so I joke about business systems. I joke because we have to talk about those business processes. Well, on the far left is an excerpt from the Hammurabic Stele from Mesopotamia, from Sumeria. It predates even Joseph in the Bible and talking about, saving the Pharaoh in Egypt from, the drought that hit them. Those ancient texts and ancient ways of doing business are some of what feeds some of our business processes for supply chains and how we plan things, right? Then the next item over is an object. It's an English wheel, so it helps us mold metal, right? It's Middle Ages kind of tech. We actually use that on B-52 engine cowling or to shape something as a one-off. That's on our shop floor. Then the middle is it's Iron Age kind of stuff, but the traditional kind of a heat treat oven and foundries, but it's Iron Age kind of stuff, right? So if I go left to right, we start with Copper Age and just coming out of the Stone Age. We got some Middle Ages, perhaps on the cusp of the Renaissance. Then we're into like, okay, we're getting a little more modern. And then, CNC machines and some of these capabilities are, 70s, 80s. They're not really that advanced. Now you get into the 7-axis, 9-axis, 12-axis machining centers. We're getting a little bit more advanced. And then, of course, over to 3D printers that a lot of us are now thinking about. And beyond that is advanced manufacturing when we work with the Rapid Sustainment Office up here at the Green, or we work with a lot of industry and a lot of you that look at what's the leading edge, bleeding edge that's out there. But this is the full spectrum of kind of what we've got. So I talk about, the 40s. Some of this even predates the 1940s. And of course, some of our business processes are extremely old. But that's kind of the challenge. That's where we're at, of leveraging our business processes and modernizing some of that and being able to leap. I love the fact we talked about the workforce, so the millennials, the Gen Zs that are coming in, along with we've got obviously the Xers and we've got the boomers, and especially us in the depots. Like I said, I've had some folks that love to work for us and they've been on the job 50 or 60 years. So you've also had that where we have a workforce that is many generations, that spans many generations. And then you've got technologies and business processes that one could argue spans a century, and in some cases, and I like to joke, but it could span millennia as well as we look at these things, right? So I like to kind of test our folks sometimes and kind of have discussions, have a little bit of fun, get you thinking. So we're here at an IT conference. We're here talking about digitizing things, and it's 2021. But when we think about inventions and some of the basic premise, I always ask folks like, well, when was the wheel invented, right? So something like that. We think about innovation, right? So I got my Hammurabi stele, probably predated some of that. When was the wheel invented? Because we talk about pushing and innovation. Look at this chart here. So about 6,000 years ago, we came up with the wheel. Now I know some of you might say, well, dung beetles, right? They roll up dung into a ball and they push it. So the concept of moving an object in a round circular manner is not even necessarily a Homo sapien thing. I'll give you that, or I'll give you a pass on that if you're that tricky. But Homo sapiens and the wheel about 6,000 years ago. But we talk about applying and the art of some of this. And you look at this picture there of a gentleman going through an airport, which I had to do to come to Oklahoma, and that was me, is we didn't put wheels on luggage till 6,000 years later, till the 70s, right? We didn't come up with some of these concepts. So when we think about, digitizing things and tying technology together and really, innovating, there's times when Homo sapiens, we were about as slow as a dung beetle trying to put some things together, right? But that's our quest right now, is a lot of stuff is coming at us. And some things like this, you're like, well, I can't believe it took us that long to kind of do that simple thing of putting wheels on a box. But if we look at these different capabilities and how we want to tie it together and think about the art and the science, and then also the skill sets needed, some of it is tied to innovation and thinking, right? So in the previous panel, they ended talking about planning and then doing. I'd say the step before that, step 0, is thinking, right? Think, then plan, then do. Otherwise, I talk about all thrust, no vector, and some of us have been in some of those meetings before, right, where you just spin and you spin and you spin. So that's really where we're trying to go, a sustainment center, and with our digitization effort, and again, kind of a multi-spectrum effort. So let's kind of talk about that. So I will go big to small. So I will get this eventually. You're like, sick, you're talking the English wheel, you're talking Hammurabi, we've not talked digitization in your plan. I'll get there, so trust me. So first, bigger scale. So like I said, our infrastructure is dated. If we talk about the national level, right, the national issue coming out of the pandemic, the previous panel talked about supply chains and fissures in those and how we're set up in the United States and outsourcing and a lot of vulnerabilities. A lot of us is also our infrastructure. Or we hear about at the national level, we talk about the national infrastructure plan. It's not just our roads and our bridges and our highways that are dated. A lot of our depots are dated. It's not just that the energy areas and how we drive up and we don't have resiliency. It's not just an issue at the national level, we have that issue at the depots. And then also we look at environmental concerns, climate change, we look at different things, and we've got to look at some of that as well. So we've got a multi-pronged attack to modernize our depots. So on the left you'll see, first is Congress is asking us through the 19 Defense Authorization Act to come up with ways to optimize and modernize our infrastructure and our capabilities and to support future warfighters. And so we came up with kind of a simple construct, is keep up, catch up, and leap ahead. So at our depots, we've got about $8 billion in revenue that comes in. And so by law, you'll see up there on the chart, it says 6% investment. So by law, we've got to invest 6% of our revenue back into our depots. Now, that's infrastructure, that could be IT, that could be equipment, but getting it back into the factory, into the people, into the quality of life, into all different things. And so we're going to meet that out and talk about that and report that, and we have to report that to Congress. The other piece is investing to catch up with technologies that are already coming at us. So if we look at the KC-46 at Oklahoma City. So the way we currently support a KC-135 going into Oklahoma City, if you've been there, the big mile-long building, 3001, they take the tail off. They move it inside the facility that was built for B-17 bombers. Well, you're not going to fit, if you've seen a KC-46, which is a Boeing 767, it's much larger. It's not going to fit even if you take the tail off. So we need new infrastructure. So we need investments to catch up. And some of that is where also our digitization effort comes in. And then lastly, we've got plans to leap ahead. So some of that is tied with the national infrastructure planning and looking at our energy expenditures and modernizing that, looking at our environmental aspects, looking at hidden infrastructure. If we look at some of the technologies you need to do paint or to do normal, say traditional aircraft and component or engine repair, there's a lot of wastewater treatment and downstream costs and overhead that you've got to invest in. And so across all those three dimensions, and then we've got our 3 air logistics complex badges there, we run through 4-dimension areas. So that's kind of where we're focused. So some of it is at the top, you'll see facilities for overhaul. That's the big upper level, above ground investment that you traditionally would see at any installation in the Air Force, hangars, if you will, right, and facilities for software. The next one down is digital. So this are our digital capabilities, and obviously I'll spend the rest of my time talking that, but quickly below that, repair and manufacturing nodes, the hidden infrastructure, so having all those conduits in place, having it be environmentally resistant and resilient with different energy needs, having it have a zero emission footprint, modernized for the future, that's kind of key, a big investment area for us. And then the equipment itself. So the equipment is very expensive. We've got billions of dollars of equipment at our aviation depots, and we're trying to modernize it at the same time, connect it to a full-up network and a digital capability. So back up to digital and Industry 4.0 concepts. So be it our software capabilities as we look at hooking them in and being able to virtually connect almost anywhere in the world, a software engineer with a user that needs, or a customer that needs capability, and to provide that and have an interface with each other to collaborate. With respect to, say, the equipment itself, say robotics and covering new technology coming in, or cobots. Or we talk about our hangars, our facilities themselves, which have to accommodate all different types of weapon systems. So we're coming up with designs to make them agile, to be able to support the various different weapon systems we have, be it a huge airlifter, or a KC-46, or a KC X, Y, or Z, if you will, or the most advanced bomber that's out there. And that those hangars or those facilities are wired in, and we can track how well they are doing or how they're being able to be sustained, as well as we can track the needs of individuals, as well as we can track the needs of the equipment itself, right? So how does it all tie together? And it takes a lot of concerted effort and investment. So projecting over the next 20 years, so if we look at how we were formed basically in the 40s out of World War II, and projecting out to 2040, over 100 years, we're looking at about, over the next 20 years, about $1 billion a year additional investment as to what we need. And we're looking at, again, leveraging some of the national infrastructure plan efforts that are going on with Congress. We're looking, and up through the Defense Authorization Acts, Congress is looking to support us in our organic industrial base. That's what this is called. And then also our own dollars as we bring in new weapon systems, and again, back through the keep up, catch up, and leap ahead. So that's broadly the larger, bigger picture here. So let's neck it down farther. So let's talk about the digital depot and how it ties in. So back to my English wheel, my Hammurabic stele, right? So we've got operations. You see the picture here. You've got folks working on a jet engine. You've got certainly the manual labor, the tactile labor. You might be working on a B-52 TF-33 engine that's solid, state-of-the-art, 1949, right? We gotta be able to deal with that. We still have to have my English wheel supported, but then we've also got to tie in the capabilities and needs of advanced manufacturing that are very sensitive to different environmental conditions, humidity, altitude. It's like baking a cake, right? It's kind of like some of that, that science of cake baking, the art. So we need to be able to track our mechanics and obviously the yields and efficiencies and whether or not we can move them rapidly to work. We had the previous discussion talked about the vulnerabilities of supply chains. And of course, you've got that where you might have a supply chain dry up on one end, so thus a production line stops on one end, and you have to move the workers to another area. So you have to retrain, you have to re-equip, you have to retool. So it has to be agile. To do that, you have to have near real-time shop floor managing and near real-time response to production delays, right? So old school, we talk about an and-on, right? You need to have the flag go up and a visual queuing. We still have that, the visual queuing and the shop flow and tracking those kind of things. But when we talk about the digital piece, is tracking it in, or if you see in the picture, a little op center up to the upper left, is where it's tied in and we're tracked, or we're through a network of teams that can see where a limitation is. And the other pieces we're thinking about is not having it necessarily be geographically isolated. So if there is an issue at one location, we could rapidly send that work or that capability or that ability to provide a response to a warfighter need to another location. Or we could partner with industry. So again, here we're talking with a lot of manufacturers from Ohio, but the concept is a maintenance-to-maintenance agreement. We could send you the data, and again, the same thing. If we have a work stop or it's a subtask that we're just not tooled or set up to provide, we could send that and virtually kind of send the information and data and get that fixed and then get it sent back into that repair shop to kind of keep things going. The other piece I talk about the big dollars we're spending and looking at spending is we've got to spend that better, right? So at the national level, they got the same issue of when you get more money, you also have a lot of waste and a lot of inefficiency. So by being able to tie all of this together and track it better, we can use better management practices. So category management is something we're looking at. So the total cost of ownership of some of these items. We have truth in advertising. We have purchased some CNC machines from certain vendors that we got them at the lowest price, right? So the contract was set up lowest price, and either it was in ALT, PLT, if you know those terms, we never got it, or we got it, but it didn't work. It sat uninstalled, became a monument, and we just set it off to the side we had one sit there for 8 years. And of course, when we bring it, the back end of that, the budget side of that is we can't depreciate it, we can't then tie it into our budgets, and thus it's kind of lost. So that's on the extreme end. We certainly don't want that, but we also don't want to buy machining centers or very expensive capabilities and not use it, not know its value, not know the cost of owning it as well. And so as we can line things up and track things, it's not just our manpower that we can track and utilize and make sure that they're empowered and that they're providing the greatest support for the warfighter. It's not just our facilities that we're working hard to improve and modernize, but it's also those machines to make sure that that machine is being utilized and needed. So be it's an English wheel all the way to the most advanced multi-axis machining center, that's how these all tie together. So sometimes a picture's worth 1,000 words, sometimes it's a video. And so we've made a bit of a video. This does kind of start now all the way back to Sumeria and Hammurabi, but it comes a little bit earlier than that. But it starts around the period of World War II, and it gives you a little bit of flavor of where the depots were at that time and what they were set up to do. And in many cases, they're the same buildings, and how we're modernizing them. And so we're going to give you a little bit of a glimpse, and this is courtesy of my crew back there, the LZT crew, CITO crew that works for Dr. Meixner. So let's, I don't think I can control the button on the video, so guys, can we roll video?
The year is 1940, while World War II.
And I think we need sound. It wouldn't be an IT conference if we didn't have like something that worked, I have to admit. So that was like the one thing I said, like, oh, these things, they never work. So I could tell jokes. I don't know. No. That's the thing. We always, videos always let me down. It doesn't matter. It could be 1971, when I was in, kindergarten, or it could be right now, 2021. Videos let me know. We ready? Got a thumb up?
The year is 1940. While World War II rages across Europe, the United States remains militarily uninvolved. In Oklahoma City, businessmen sense shifting alignments and advocate for an aircraft repair facility. The War Department grants their request, and construction begins on the Midwest Air Depot. Utah and Georgia also begin construction on repair facilities.
Flash forward to present day. The still bustling air logistics complexes in Oklahoma City, Oklahoma, Ogden, Utah, and Warner Robins, Georgia are now home to over 30,000 employees and millions of square feet of industrial space.
The complexes are big business and key to America's defense and the local economies. But amazingly, while modernization has occurred, many of the processes and facilities have not appreciably changed since the days of World War II.
Daily, at all three ALCs, maintenance of legacy aircraft and modern weapon systems collides in facilities that are part museum and part Hollywood. Today's complexes are made up of amazing men and women who, on a daily basis, are performing heroic actions as the Air Force's weapon systems, engines, and numerous components are dismantled, restored, and put back into service. These artisans keep both aging and modern systems maintained, while using equipment and facilities well past their useful life.
But this is not sustainable. We need to honor the legacy of the depots and equip them for the future. We need to capitalize on technology that we use in our everyday lives and look forward to the future while protecting and securing these resources from cyber attacks and threats of a new digital age.
Enter Digital Depot. Imagine a future where shop floor personnel have the data and tools at their fingertips that they need to quickly and efficiently do their jobs. Imagine a depot that takes full advantage of smart technology. Digital Depot efforts will modernize the AFSC industrial floor, saving time and money, as well as increasing quality as AFSC supports all aspects of Air Force operations and enables the Air Force to generate combat air power. In short, imagine a shop floor like this: human-to-machine interface. Machine data that drives real-time business process automation. Real-time views of capacity, quality, and performance across all ALCs. Machines that provide day-to-day reporting functions, unlocking the bandwidth of our people to focus on analysis and improvement.
Machine-to-machine interface. Machine learning and artificial intelligence that provides preventative maintenance and production automation. Securely open data transmission from shop floor machining functions to enterprise analytic capabilities.
Maintenance and process improvements across all ALCs through deployment of cutting-edge technology, effortless connectivity using 5G, and threat detection and remediation.
The evidence of greatness lies all around us.
Pocket efforts have already begun, transforming the depots into 21st century industrial spaces. These efforts include establishing a dedicated control systems network, industrial Internet of Things pilots, near real-time monitoring of CNC machine mission capability, deployment of sensors powered by temperature and vibration, large-scale 5G pilots, and robotic process automation.
Now, the burden is on us to continue the incredible work that started in 1940, to carry on the technological advances that the 21st century has brought us.
As a team, let's work together to ensure that this legacy carries far into the future. It's easy to see the criticality of the Air Force's depot to the security of our nation. Much harder, though, is the task at hand, protecting our organic industrial base for future generations of warfighters and sustainers.
Okay, so that gives you a little bit of a flavor. At the end, it gave you hints as to some of the details. So, as usual, to do this, you always have to first have a cool acronym, right? So that's the law of all these things. So we debated, like Lord Vader or Thanos, but I lost out on some of those. But there is a Greek goddess of wisdom and artistry. So I talk about this as a combination of art and science, back to the wheel, but not taking 6,000 years to apply some of that. And so, we got the concept of the AFSC technology hosting environment for next-gen automation, or Athena. And so the stage is set, and we're introducing Athena. So that's what this is a stage, and, there's the spotlight on her. And there's three key pieces to Athena. And so the video kind of touched on some of it. I talked about the capabilities of it, of saying a machine on a network that we can track, and using, again, Internet of Things capabilities, that we've got and you got the examples there underneath it, like the digital infrastructure, like the ushers, and the data environments like the orchestra, and again, the stage. But what we can do to ID, apply, and scale capabilities across our depots. So the video highlighted and showed some actual in-place capabilities we have right now. So we've got innovation centers that are kind of operating at a higher level, work and coordinate with RSO a lot, the Rapid Sustainment Office. They get requests all the time to reverse engineer, 3D print, additive manufacture, or provide different capabilities. So we've ID'd capabilities. We've got enclaves of support and capabilities that are digital. But now we want to apply and scale some of that, and then, of course, bring in some greater capabilities, working with industry and sending out some contracts to provide support. So that's where we're moving. I don't want to take much more because I want to give a chance for a couple questions, but I will tell you that we're really excited about this. We've got some dollars in the out years. We're working to expand this rapidly. We're working underneath of the rubric of the digital campaign with Air Force Material Command as well. And this is also tied into our organic industrial base planning that we have to send up to Congress on an annual basis too, so up through OSD. And we got good connections. My predecessor in my current job is Mr. Steve Marani, who's now up at OSD over all of this. So we've got friends in high places. So for you, for key takeaways, again, the big thing with us is that, industry, stay bleeding edge and innovate. We want to save that space for you. Innovate, think, right? Then plan, then do. And then when you get ready to plan and do, we'd love to be there with you and partner with you in different agreements, and to be agile together and think about that space as to how we could work together. The other piece is we've got an industry day coming up, so for our Internet of Things application, and a lot of good effort in that space. So down in Oklahoma City, we are going to have an industry day, and you'll hear more about that in the near future. And then lastly, you always got to have someone to talk to, and it's a person far smarter than I that's probably going to ask me a question here in a minute, but Dr. Tim Meixner. And so if you need contacts, information, and of course it's tied to this entire event, Tim's been huge in this. So if you ever want to know what you can do to tie back into our organic industrial base, or our efforts to modernize our depots, or lower level, this digital depot aspects, the Internet of Things applications, or on the network and capabilities in 5G, let's say, or next G capabilities, or if you're a CNC maker, we'd like to talk to you, right? Okay, Tim, toss to you.
So we've got a few questions, sir, and just for time hack, we're at 13:50, right? Okay. So got a few questions here. Well, more questions. I think there's
questions than time. That was my intent. So
yes, sir. So first of all, appreciate the coming up from Oklahoma to spend some time with us and give us some good insights into where AFSC is headed. I think we got a softball here. Can we get a copy of the Digital Depot video? Is it posted anywhere?
That's easy. Yeah, so we can do that.
I do believe we've got PA release, obviously.
We showed we'll get the sound connected faster.
Yes, sir. Well, the sound, they just asked for the video. The sound is...
Well, then the sound is extra. Sound is extra. There's a fee.
All right, so question for you on... they keep on coming through. As an industry leader once said, if you aren't at Industry 3.0, which is basically IT kind of static, systems, if you're not at 3.0, don't even think about going to Industry 4.0. Does that statement resonate with you? So essentially, the cyber physical world that we talked about versus the standalone IT, kind of isolated, not really connected. So what do you think from an evolutionary aspect of we've got some pockets, but we're not at 3.0, but how do we get competitive? And I think your point about OID.
And that's my wheel point either. It's like, well, we perfected the wheel a lot sooner than we even put wheels on luggage, right? We had Maseratis and Ferraris on all kinds of cool wheels and BBS rims. I remember I was a lieutenant and had a Mazda Miata with cool BBS rims, on the cusp of them still sorting out how to put wheels on luggage. So you have to walk and chew gum at the same time. And like I said, as much as it's the bane in my existence, I still have to work with the business systems IT transformation and our Air Force personal struggle with that, while at the same time we do have pockets of excellence where we ID and apply certain capabilities, and then we've got to scale. The issue is when we go to scale. We don't want to scale things that are dumb, different, or dangerous. I'll kind of challenge, General McDew, previous Transcom commander. You just say avoid things that are dumb, different, or dangerous. I think when we ID or we experiment, it's okay to take the Elon Musk aspect and fail quickly. Just don't fail large scale, right? Fail early and then learn from that and then get to win, get to scale rapidly.
Yes, sir. Another question that kind of hits to the audience here in cybersecurity, but some of your inherent security comes from the disconnectedness, easy for me to say, of your systems. Yeah. Are you engaged with the mission defense team community to ensure security into the future for these connected?
Good question. So absolutely. So the other side of us, and with Dr. Mike, we work wargaming and red team and trying to figure that out, and it's almost fun to try to think about ways to see our vulnerabilities but then fix them. But you're right. I mean, the fact that nothing is connected, we're awesome at that, right? And so having disconnected enclaves and people doing things in different directions, but it's not affordable. It's very expensive. You can't standardize things. So getting back to the basics of Deming and Lean or Gemba. And so, it's kind of it's a fine line, and I get that. We have some vulnerabilities. Same thing with the energy grids, right? We want to connect them more and have greater resiliency. But the risk, too, is if you have single-point failures. Look at where we were with the ice storms in Oklahoma and Texas last year. Look at look at New York City. Look at what happened with that storm Ida that came up. And that's not enemy attacks. That's just like Mother Nature attacks. So I think resiliency, again, planning things out. It's also fun to pretend you're the nefarious agent and go in and get some of this stuff, and then how to kind of help ourselves with MDTs, mission defense teams. That's kind of where we're working. And yes, you're going to have, I don't know how we're going to hook up my English wheel after I talk to all that anyway. So some things you're just going to have that art. Back to Athena, the goddess of artisanry and wisdom, is that we still will keep that artistic piece. There will be a level of resiliency that I think will keep old school, because we're good at old school.
All right, sir, we are over time now. Really appreciate your time. Please join me in thanking Mr. Sick for his participation.
All right, thank you. Thanks, everybody.